So now we will see what is initialization, what do we mean by initializing a solution, how to conduct initialization of solution within CFX. This is an extremely critical area in order to start and in order to progress your simulation calculations, and it affects your simulation from a varied angle, where it can also make your simulation diverge, as well as it can lead the simulation to take a longer time to produce results. So it is a very important area which decides how your simulation progresses. So initialization is the process by which all the unspecified solution field values are assigned at the beginning of the simulation. So it is a sort of an initial guess which can be set in three ways. First is solver automatically calculates the initial guess, which the user does not have any interference in that. Second is initial guess is entered by user. The user decides what are the values of the field variables that are to be entered. And the last is previous solution is used as an initial guess, where a already obtained result is used as an initial guess for next simulation. Where do we specify this particular initialization in our CFD or CFX simulation setup? We go to simulation flow analysis and say insert global initialization, which means a global initialization is done for the entire CFD domain. In that global initialization settings, we have different variables that we have to initialize. First is velocity, next is pressure, then depending upon what equations you solve, there is turbulence, as well as rest of the values like temperature if you are solving heat energy equation. So here we can give initialization by giving the three components of velocity, giving the pressure value, as well as the turbulence variable values. Also, for individual domain, we can specify for each domain its own initialization. So we can go to each domain. Let's say, for example, here there is a housing domain in which we go and edit, and there is a tab called initialization, and when we activate that, there is a local initialization only for that domain. These values will be applied only for this particular domain, not for the entire global CFD domain. The settings are same depending upon which equation you solve. There will be velocity, pressure, turbulence, heat, etc. So let us see the first option, which is automatic initialization, in which CFX solver calculates values for the solved variable at the start of the solution based on boundary condition and domain settings. So in that we do, let's say we want to do that particular automatic initialization for CFX for velocity. What do we do here is that we say automatic with value, but in static pressure we say totally automatic, which means the solver itself will calculate the static pressure initialization depending upon what sort of values are there for the boundary condition and domain settings. The second is basically is entered by user, in which the user can enter the initial guess as a constant expression or CEL expression. Here we are saying that it has to be automatic with value, where the user is entering all these values. Also, there is an expression used for W velocity as seen here. And the third option is using previous solution, which is actually present when we define the run in CFX solve. This is the start panel of CFX solve, where we actually give the definition file, but here we say initial value specification and specify the already obtained result file in this particular drop box. And this particular result file is used in order to start your calculations. The results are interpolated from the earlier result file if the mesh does not match. So to summarize, in order to approach a converse solution most effectively, CFX offers several initialization options, which is given at time t equal to 0, or start of the solution, start of the iterative process in steady state, and the better the initial guess, the quicker the convergence.